What is a vector? Given 2 points A and B, if I were to connect A and B, we end up with segment AB, which we denote by AB inside brackets. However, if I were to refer to the segment as BA, it would be the exact same segment as segment AB and segment BA are the same. However, if I were to give segment AB a sense of orientation from A to B, I would then have an oriented segment, which is what we refer to as a vector, and we denote it by AB with an arrow to indicate the orientation from A to B. If I switch the sense of orientation from B to A, I end up with a different vector BA, where vector AB would be negative vector BA, which is what we refer to as opposite vectors. Alternatively, a vector is, in fact, the displacement from one point to another. Then a vector is defined by its origin, which is its starting point, and by its extremity, which is its end point. And a vector is first characterized by its magnitude, which is the length of the vector, denoted by vector AB between two vertical bars, and is defined by distance AB, which is the distance between A and B. Vector AB is also characterized by its direction, which consists of the steepness or the slope of the segment, and the sense of orientation, which in this case is from A to B. Now, when are two vectors equal? Given two vectors, the first one is denoted by vector AB as the origin is A and the extremity is B. The second one is denoted by vector CD as the origin is C and the extremity is D. So to compare them, I would first note that the distance AB is equal to distance CD. Then the two vectors have the same magnitude. Additionally, they are parallel, and they have the same sense of orientation. Then the two vectors have the same direction. Same magnitude and same direction imply that the two vectors are equal, which we denote by vector AB equals to vector CD. Now, if we switch the sense of orientation of the second vector, now we are comparing vector AB to vector DC, as now D is the origin of the second vector. We would, in this case, have opposite vectors. As distance AB is still the same as distance DC, then they still have the same magnitude. They are still parallel, but now they have an opposite sense of orientation, which means that the two vectors have opposite direction. So same magnitude and opposite direction implies that the two vectors are opposites, which we denote by vector AB equals to negative vector DC. Finally, what is a zero vector? Given a vector AB, vector AB would be a zero vector if the origin and its extremity confound at one point, which means that point A and point B are the same point. So a zero vector is represented graphically by a point, which we denote by 0 with an arrow. The magnitude of the zero vector is equals to 0, and the direction of a zero vector is undefined.